In this video, I'm going to talk about reducing rational expressions. And a rational expression is a fraction where the numerator or denominator or both are polynomials. Numbers like a half are actually rational expressions under the definition, but most people reserve the term rational expressions for the first three examples here. Now, let's start with this first one. It's monomials, and so it's something you're probably pretty comfortable with. We can reduce 24 and 40. We can reduce this a with one of these a's to get just an a in the denominator. If you're unsure how to reduce 24 and 40, I'd really recommend prime factoring. 24, for instance, is 8 times 3, and 40 is 4 times 10. After reducing the common factors, we can see we get 3/5 with an a in the denominator. Most of ours, though, are going to be polynomials like this. So here's one for you. Please try reducing. Well, the 3 and the 6 can reduce to a 2. This k can take one of these factors of k, and so we'll get just 2k in the denominator and 2k plus 1 in the numerator. We don't need the parentheses anymore. Once we get here, though, we have to stop. These 2k's cannot be reduced since this first term is part of a sum, and we can only reduce factors. Try this one. You're going to have to factor out the GCF in the denominator. After factoring out the GCF of 2, and then reducing the common factor of 2 to get 10 in the numerator, we have our simplified rational expression. Try this one. Here we have a greatest common factor of 9 in the denominator, and in the numerator we think of this as 1 times n minus 9. That way we do have factors which can reduce, and we're just left with 1/9. Here's another. Make sure you factor out the entire GCF from the denominator. The 28 and the 14 share a 2 and a 7, but even more, they share a 14. So the GCF in the denominator is 14x, and then the 14 and the 32 can reduce, and the factor of x can take one of these to leave 1x in the numerator, and this is our final form. Sometimes students want to distribute here, but please don't. If you leave it in factored form, then when I look at it, I can see immediately that there's nothing left to reduce. If it was a 14x plus 7, I'd have to spend a little bit of time trying to figure out whether I could or couldn't reduce if I factored. Try this one. After factoring the numerator, thinking of the difference of two squares, and thinking of the denominator as 1 times the quantity x minus 2, I can reduce these factors of x minus 2, and that leaves x plus 2 over 1, or just x plus 2. Here's another. You're going to have to factor both the numerator and denominator this time. In the numerator, I have a greatest common factor of 9. In the denominator, I'm looking for two numbers that multiply to negative 60 but add to negative 4, and negative 10 and positive 6 come to mind. So I factor. Notice I have a common factor of b plus 6, reduce, and here's my simplified form. Try this one. After factoring both the numerator and denominator and reducing the common factor of p minus 2, here's what I'm left with. And again, the 2p cannot reduce since in the denominator it's part of a sum. Try this. After factoring both the numerator and denominator, I notice there's a common factor of n minus 2. I reduce the common factor and I'm left with n plus 6 divided by n minus 5. Here you'll have to use grouping in the denominator. After factoring and reducing the common factor of x minus 7, here's my result. Now, this is a very special case. I have m minus 2 in the numerator and 2 minus m in the denominator. In situations where you have subtraction and for each of your variables or numbers you have the same 2 but the order changes from left to right, in that one special case this can be reduced to a factor of -1. And I have a rationale here in these steps if you'd like to go through it. On the other hand, most people just memorize the fact that if you have, for instance, m minus 2 divided by 2 minus m, that simply reduces to -1. Try this one. After factoring the numerator, I recognize I have 3 minus x and x minus 3, and those can be reduced to a factor of -1. And you can leave it -1 times x minus 6, or you can distribute and get negative x plus 6. Well, I hope this video has helped with reducing rational expressions.